All right. So a point in the polar coordinate system is defined by the ordered pair r comma theta, where r is the point's distance from the origin, and theta is the measure of the standard form angle whose terminal side intersects that point. What does this sound a little bit like, this description? This should sound kind of familiar. The distance formula? What other object is described by a distance and an angle? A vector.
Oh no.
So this is got a lot of similarity to what we talked about when we talked about dimensional vectors. Yeah. Yeah.
That was the one thing. This looks like, what are we talking about?
It looks like a spider web. I thought so.
Yeah, I really thought
I really thought we were going to see I can't go down the street.
Wait, we're back on vectors?
Welcome. Yes, welcome to last class. Oh, it's just like the things in the boat game. Yeah, it's just like the radar and all that.
Yes. So what I just passed out to everybody is some polar graph paper. You can also find this same. You can find this same handout on PowerSchool if you look at the materials for this chapter. If you need another copy or whatever, you can get it there. But I wanted to give you guys one of your own that we can look at together. So you'll notice that when you look at this, we still see a pair of like perpendicular axes, right? Like we do in the Cartesian system. Everybody notice that? Okay. But we also have all these other like diagonal lines going on in here. Each one of these slices of pizza is 30 degrees, or if you prefer, pi over 6 radians. So this is like 30 degrees. This one would be 60, 90, 120, etc. Or you could be counting up sixths of a pi, like 1 6, 2 6, 3 6, 4 6, etc.
Are we allowed to take notes on this?
Yeah, this is for you to use.
I didn't know if like this is like a homework all.
Again, there's a digital file of this also on the PowerSchool page. So if you want to print out another one because you're going to use it to do some homework stuff on rather than drawing your own, you're more than welcome to do that. I figured I'd give you one today that you can take some notes with, that you can do some homework on, and you can just print as many as you need whenever you need them, okay? Everybody's okay with that? Though in terms of the angle measures, that each slice is 30 degrees. And you'll notice we have all these little circles in here, right? So this first circle is a unit circle. The radius on that circle is 1. The next circle has a radius of 2. We call it a 2-unit circle. The next one has radius 3. We'd call that a 3-unit circle. And so on. Is everybody okay with that idea? They can't all be unit circles because they're concentric. If they're all unit circles, they just all overlap one another. So their radii are all different. But they're all centered at the origin. So in the Cartesian coordinate system, we refer to the point 0, 0 as the origin. In a polar coordinate system, we call that the pole, like the North Pole. Exactly. It could be like the South Pole, depending on which end of the Earth you're looking at. Not like the flagpole. All right, so let's talk about how we go ahead and graph a point then. So I'm going to graph a couple of different points here. Okay. So the first thing I'm going to do is graph the point 3, 120. So what I like to do is I start by identifying the line that 120 degrees lies on. So here's 0, 30, 60, 90, 120. So the line that I'm interested in is this one. Everybody okay there? So then I'm going to start from the origin, and because 3 is positive, I'm going to go up this line. Let me rephrase how I want to say this. This is going to make more sense in a moment if I think about it this way. So here is my line for 120 degrees. I only want that half of it. It'll make more sense when we do the next one why I'm doing it this way. And then I'm going to count 3 units on this line. So 1, 2, 3, where each circle is a unit. So this is my point 3, 120. Okay? That's it. We've plotted the point.
So, but then it's gonna be like harder when it's gonna be like 4 points aside.
So the next one we'll look at is going to be the point -2 and pi over 3. Stop talking, please. So first thing I'm going to do is I'm going to count to find the line that pi over 3 lies on. So we have 0, pi over 6, 2 pi over 6, which is the same thing as pi over 3. So we're going to be looking at this line. But because we're counting -2 units on that line, we actually don't want this side. We want that side of it. So we want the opposite side. So we want 1, 2. Because the 2 is negative, so you're on the opposite side of the line as you were before. Okay? We'll do one more example. Let's look at one where both this line and the angle are negative. Everybody okay here? So we're going to do -1, -100 degrees. So again, I'm going to start by counting to figure out where -100 is. Remember, which direction do I go for a negative angle? I go clockwise, right? The opposite direction as we were going before. So here's 30, 60, 90. So 10 more degrees is going to be like a third of one of these wedges then, right? So maybe it's going to be, oops. Like that is an estimate. Oops, actually I didn't want to draw the whole thing. Sorry. Like that. Everybody agree? Okay. But my measurement for R is negative. So I actually want the opposite side of that line. So what I really want is the part of it that's over here. So this is 1, -100. It's actually in the first quadrant. Is everybody okay with what I did there, Ingrid?
So when you do these, like, in the homework, are you supposed to draw the line and the dot, or
Just the dot. I'm just trying to draw like what I'm doing with my finger on my sheet of paper, so you guys can see what it is. No, we're just plotting a point, right? So the point is just the point. I'm just drawing these lines in here so you guys can kind of see what I'm doing with my eye or my finger. Good question. Is everybody okay there? Okay. So let's take a look back at this point here again. Is that the only way I could represent that location? No. Right? What else? What other way could I represent this? Add 30 degrees to each side. Raul? Okay. So what Raul is saying is if I have an angle that's coterminal by adding or subtracting 2 pi, I'll end up with a point that's still in the same location, right? Is everybody okay there? There's another way to do this. What if I had a positive 2? Not a negative pi over 3. But what I want is, instead, I need like this angle, right? So how would I get that? Yeah, so I'm just really talking about adding this much. Yes. So it'd be like 240. Yep, exactly right. Is everybody okay there? So let's formalize these two ideas, because these are really the two major, or the two ideas, the two ways that we can get a point that's also in the same location. So given a point P, whose coordinate is r comma theta in the polar coordinate system, any other point that coincides with P must be of the form. When I say coincides, do you guys know what I mean? It's the exact same location, right? Any point that's in the exact same location. So one of them is the coterminal points, where the angles are coterminal. And the other way is where we look at going to the other end of the line directly, right? And I guess this is where n is just some integer value. And if we have a way to do this with radians, we should probably also describe the way to do that using degrees. Again, where n is just some integer. Okay. It's worth pointing out here that these parentheses are not optional, that is absolutely like a required set of parentheses, that we make sure we need to add that 180 degrees before we add the 360s for the coterminal part. So I can't just say, negative r comma theta plus 3 pi n, because pi plus 2 pi n is 3 pi n. Pi and 2 pi n are not like terms because they don't both have n's on them. So you can't really do it that way. Okay? All right, so let's practice using this definition here. So PCPs here is just polar coordinate points. So I want all the polar coordinate points that correspond or coincide, excuse me, with this point. How many of them are there? Okay, how many a lot? What? Infinite, right? So we're not going to list them. We're going to describe them with like a formula, kind of. Okay? So there's two ways to get coinciding points. One way is by finding things that are coterminal. So there's our first set of coinciding points. Notice to find that I just used that, right? Everybody's okay there? My second set of coinciding points are going to be like using the opposite end. So here we can simplify things a little bit. 5 pi over 6 plus pi is just going to be 11 pi over 6. Again, for every n. So those are my answers. Why do those describe infinitely many points? I'm sorry, what? Because n is an integer, and so we're doing all integers there. Yep, and since there's infinitely many integers, we have infinitely many points. Good, good, good. You want to do another? Okay. Take a moment, try this one on your own. We'll go through it here in a second. So just try this in your notes or whatever. We'll go through it together in just a moment. Yo, you may. Okay, so we have our coterminals. That one should have been easy. And then negative 234 plus 180 gives me negative 54. And that's my other set. Everybody okay there? So that should be fairly easy. So next topic we're going to look at is converting polar coordinates. That's things that are of the form r comma theta to Cartesian coordinates, or sometimes we call the Cartesian coordinate system a rectangular coordinate system. So just x, y's. So that's what we're going to be working on. Okay. So if point P has the polar coordinates r theta and the rectangular coordinates of x, y, then the following four relationships hold. X is equal to r times cosine theta. Y is equal to r times sine theta. R squared is equal to x squared plus y squared. And tangent theta is equal to y over x. All of these are a direct consequence of each of these polar coordinates being a point on a circle with radius r. Right? Okay. What have you been doing? We've been sitting here for like a few minutes. Yeah, Isabel. It's probably because you have 2 tablets going.
Probably.
It's twice as many tablets as you need, and infinitely many tablets than you need right now in this class.
Oh,
Yay.
God.
Especially if you're taking notes by hand. Well, what do you need 2 tablets for? Okay. So, of these 4 equations, which are the 2 that are going to be the most useful to me? So we have 4 equations that I can use to do my converting. Which of the 2 are going to be the ones that are going to be useful to me? The x equals and the y equals equations, because I want to create an ordered pair of x, y's, right? So x is going to equal -3 cosine of 148. And then y is going to equal -3 sine 148. When I type this into my calculator, I get about 2.544144288. And when I type this one in my calculator, I get 15897577793. So let's just round that to 2 decimal places, seems reasonable. So there's my answer. Not too bad, right? Okay. What if we want to go the reverse direction? So would be if I want polar coordinates, I want an r comma theta, right? That's what we mean by a polar coordinate point. So of these 4 equations up here, which are going to be the 2 that we'll be interested in, r squared and tan theta. Okay. So if I do that, okay with that? So far, so good? Now, we need to make a choice here whether we want to use the positive for r or the negative for r. My suggestion to you is just always do the positive. It makes everything a little bit easier because you don't have to worry about like reversing anything. Everybody okay there? Okay. So I'm going to do tan theta of, or is equal to negative, 2 over negative 3. What do I have to be careful, though, about tangent? Yeah, the range of tangent inverse. So probably what I'm going to do here is I'm going to take tan inverse of the absolute value of negative 2/3. And then think about where the point negative 3, 2 is. So what quadrant is my solution in here? Should be in quadrant 2, right? I'm going to actually call this alpha. So the angle that we're going to find right now is alpha, and the relationship between alpha and theta is 180 minus alpha. Yes?
Why did you do that absolute value?
Because if I did tangent inverse of negative 2/3, it's going to give me a negative answer in the 4th quadrant. Not what I'm looking for. In general, if I'm taking, if there's any negative sign anywhere in this, it makes it easier to just take the inverse of the positive fraction. And then we're going to do add or subtract some multiple of either 180 or 360 to kind of get our real angle measure. Does that, you kind of remember doing that from first semester a little bit?
Yeah.
Okay. So in this case, this value turns out to be like 33,690,06753 when I type that into my calculator. So that becomes 146.300325. So I'm going to have the square root of 13, comma, 146.31. Again, I'll just round to 2 decimal places there. What do you guys think on that? It's a little bit more, but not so bad, right? Looks very much like a first semester trig problem, right? So it should be something that we're reasonably comfortable with. Let's stop here.